Nowadays, people no longer see cars as mere means of transport to comfortably move around. The traditional vision of the car has gone down in history. Cars are now an essential part of our lives, through which we express our personal style. In parallel, the automotive industry has evolved significantly. The rapid growth of car companies has grown exponentially. Now we are at a turning point, where it is necessary to adopt a qualitative approach to offer better ideas and solutions to customers. It's the opportunity to continue advancing in technology.
But how do airbags work? The moment of impact is detected through several sensors and an electronic system evaluates which airbags should be inflated. The corresponding components are activated. Gas is generated and the bag is inflated. Only a few milliseconds have passed since the crash and we have the airbag ready to cushion the impact. Let's look at the fact that a certain amount of gas must be generated very quickly and in a controlled manner. The answer is found in sodium azide, a stable compound, but when heated to about 550 kelvins, about 277 degrees Celsius, it decomposes violently and releases dinitrogen, the gas that inflates the airbag. But there is a small drawback. The sodium released in the previous reaction is very dangerous, as it is very reactive and potentially explosive. You have to eliminate it. And how do we eliminate it? By making it react harmlessly in some other innocuous substance. To do this, the airbag contains another solution, potassium nitrate, that reacts with sodium, producing potassium oxide, sodium oxide, and more nitrogen. But a new problem arises again. Also, sodium oxide and potassium oxide are highly reactive and very dangerous. For that reason, in the airbag there is a third substance, silicon dioxide. This substance reacts with the previous ones to form a compound called alkaline silicate, which is a harmless solid substance in the form of a white powder.
As you can see on the screen right now, these are the chemical reactions which are responsible for the deployment of the airbags. Through calculating the enthalpy of each reaction, we learned that the reaction is exothermic, which means they release heat. It is important because airbags are subjected to extreme temperatures, up to 900 degrees Celsius during deployment. Because of this, engineers must take entropy and enthalpy in count in order to make sure that the material is strong enough to take on high temperatures. Also, it is important to measure entropy and the change in free energy in order to see if the reaction during the airbag's deployment is spontaneous or not. As you can see, the reactions are spontaneous since the change in free energy is negative. This is important since the airbags have to deploy spontaneously during a crash in order to save the passengers' lives.
As you can see on the screen, we add all the reactives of the three formulas to get what is needed to inflate the bag. And in order to the airbag to inflate, it needs 839.76 grams of reactives.
Chemistry is very important in people's lives, and especially in science, since knowing how to use it properly helps to keep innovating in many aspects, and a very clear one are the airbags.
Important to know that chemical reactions and changes that take place during the deployment of an airbag, since airbags are devices which were made to save our lives in case of a car crash. And because of this, it is important for us to understand how and why the airbags deploy spontaneously, and also how they can take on high temperatures during deployment without suffering changes in their materials.
In conclusion, thanks to the project, we learned the importance of the chemicals involved in the solution to inflate an airbag. Moreover, it helped us to see how the airbags work and how the chemistry is applied in our surroundings.